Okay, in this video we evaluate the integral from 0 to pi over 2 of sin x over 2 minus sin 2x. Note that we cannot use u substitution directly since we evaluate, for example, u equals 2 minus sin 2x or u equals sin 2x, then du equals 2 cosine 2x, and this can be cancelled out with sin x, which is in the numerator. So we have to convert the integrand into another form. Then we can use another integration technique or even u substitution again. So this equals to from 0 to pi over 2 sin x over, now 2 equals to 1 plus 1 minus sin 2x equals to sin x cosine x dx. Now sin 2x equals to 2 sin x cosine x. This is the double angle identity of sin 2x, and this equals to from 0 to pi over 2 sin x over 1 plus. Now we convert this one to sin squared x plus cosine squared x. This is also another trigonometric identity. So this equals to 1 plus sine squared x plus cosine squared x minus 2 sin x cosine x dx. Now this equals to from 0 to pi over 2 sin x over 1 plus, notice that sin squared x plus cosine squared x minus 2 sin x cosine x is the expansion of sin x minus cosine x squared dx. Now notice that if we let u equal sin x minus cosine x, then du equals to sin x plus cosine x. So we can add here in the numerator plus cosine x minus cosine x. Now cosine x minus cosine x is 0, and this does not affect the integral value in any way. So this equals to, now we split this into two fractions and two integrals. This equals to from 0 to pi over 2 sin x plus cosine x over 1 plus sin x minus cosine x squared dx, minus from 0 to pi over 2 cosine x over 1 minus 1 plus sin x minus cosine x squared dx. Now there is a property of the definite integral, which is from 0 to a f of x dx. This equals to from 0 to a f of a minus x dx. This can be easily verified using a u substitution of, for example, x equals a minus u, or on the right hand side u equals a minus x. And now using this property, this equals to from 0 to pi over 2 sin x plus cosine x over 1 plus sin x minus cosine x squared dx, minus from 0 to pi over 2. Now we use this property. We have from 0 to pi over 2 cosine x cosine of pi over 2 minus x over 1 plus sine pi over 2 minus x minus cosine of pi over 2 minus x squared dx, and this equals to from 0 to pi over 2 sin x plus cosine x over 1 plus sin x minus cosine x squared dx, minus from 0 to pi over 2. Now cosine of pi over 2 minus x is sin x. And then we have 1 plus. Also sine of pi over 2 sine of pi over 2 minus x is cosine x, minus cosine of pi over 2 minus x is sine x squared dx. Now notice that this part of the integral is equal to our original integral, since we have from 0 to pi over 2 sine x 1 plus cosine x minus sine x squared. This is the same as sine x over 2 minus sin2x. So if we have our original integral equals I, then we have I equals to from 0 to pi over 2 sine x plus cosine x over 1 plus sine x minus cosine x squared dx. This is minus I. So if we move this minus I to the other side, we have 2i equals 2 from 0 to pi over 2 sine x plus cosine x over 1 plus sine x minus cosine x squared dx. Now for this part we use a u substitution, trigonometric substitution, that is u substitution, u equals sine x minus cosine x. Then we have du equals cosine x plus sine x dx. And notice that we have this in the denominator. So we have 2i equals 2. This is du over 1 plus u squared, and this equals to tan inverse of u. And this equals to, in terms of x, to tan inverse of sine x minus cosine x from 0 to pi over 2. This equals to, now we have the upper limit of the integral pi over 2 is equals to tan inverse of pi over 2 of sine of pi over 2 is 1 minus cosine of pi over 2 is 0 minus tan inverse of, for the lower limit 0, sine of 0 equals 0 and cosine of 0 equals 1. This equals 2. Now tan inverse of 1 is pi over 4 minus tan inverse of negative 1 is negative pi over 4, and this equals to pi over 2. Remember that this is 2i, and therefore we have I equals to pi over 2 over 2, and this equals to pi over 4, and this is the final answer.